Well, any fraction, if the bottom of the fraction is getting bigger and bigger, then the fraction is getting smaller and smaller. Okay, so that's going, and it keeps going forever, bigger and bigger and bigger on the bottom. So we just say that that's going to get, the limit is going to get closer and closer to 0. So the limit is 0. Okay. And then we want to look at a couple problems where you actually have to think about it as if you are plugging in infinity. Okay. So plugging in infinity. So let's say we have the limit as x approaches infinity of, we'll say e to the x plus 1 over x. Alright, so let's think about this now. This is not a rational function, so we can't just go to our exponent rules. It is still going to be a horizontal asymptote, but it's not a rational function that we can just use exponent rules on. Okay, so we have to think about this as if we're plugging in this infinity here. Okay, so e to the infinity plus 1 over infinity, and we just remember what we just said about when a fraction is getting bigger and bigger on the bottom, the limit is what? 0. So that just cancels out, and e to the infinity is going to be infinity, right? Even faster. Okay? Not that that's possible, but yeah. So the limit is infinity because it's just going to keep going up and up, e to the infinity. Bigger x gets, this is just going to keep going up. Let's look at, I am going to graph this, but let's look at the other asymptote first. So this would be still a horizontal asymptote, but as x approaches negative infinity, we're looking at the left side. What's happening on the left? See, when you look, x approaches positive infinity, we're looking at the horizontal asymptote, but only on the right side of the graph. As x approaches negative infinity, we're looking at the horizontal asymptote on the left side. Okay? The e to the x plus 1 over x. So if we think about that now, that's e to the negative infinity, since we're plugging in negative infinity, plus 1 over negative infinity. Now, let's look at the 1 over negative infinity first here. That's actually still going to go to 0. Because even though the number's still getting bigger, it's going to be from the negative side, but 1 over negative a million, 1 over negative a billion, 1 over negative a cajillion, okay, that's getting closer and closer to 0 still, even though it's negative, okay? So that's still out. Now, e to the negative infinity, what does a negative do on an exponent? Puts it on the bottom, right? It puts it on the bottom. So this is really 1 over e to the infinity. So now we actually have a situation where, because it's a negative exponent, it makes it so that the bottom of the fraction is actually getting bigger and bigger. Okay? So that means that whole thing's going to end up being 0. The bottom, this fraction down here, the bottom's getting bigger and bigger, which makes the whole thing equal to 0. Okay? Let's graph this so that we can get a good idea of what this looks like. Yeah. Could what?
Like, you know how we said about 1 over negative?
Yeah.
So we have thought of our answers like that. Just like say it was 0. Like I know we tested it off, but could that possibly be a different answer?
Well, no, because you got to look at the other part too. You got to look at all the parts. All right. But let's graph this. We had e raised to the x, and whoops. E raised to the x. What was it? Plus 1 over x. So if you graph that, now look at this graph. So as this goes to the right, there's no horizontal asymptote, right? It just keeps going up and up. It's going to keep going up. So that was this that was this infinity right here. As we go to the right, that graph keeps going up. That's a limit of infinity. Alright? As we go to the left, pull this over here. As we go to the left, look what happens. This thing approaches 0, right? That's our 0 down here as x approaches negative infinity. So it can really make it a lot more clear if you look at a graph or something, okay? But I do want you to practice this idea of plugging in the infinity. Is there a horizontal asymptote here? I'm sorry, is there a vertical asymptote? There's a vertical asymptote at 0. Because from the left it's going down and from the right it's going up. Okay? So there is a vertical asymptote at 0 here. Okay? Let's see, is that all we need for now? Yeah, okay. So let's see, we're looking at same page again, 823. And 47 to 60. 47. Real quick, you guys, I forgot to do one example. Let's say, this is going to be a real quick example. Alright, limit as x approaches infinity of cosine x over x cubed plus 4. Okay? Now it's a fraction. Okay, so it's infinity. So you gotta, when it's infinity in a fraction, you gotta decide, is the top getting bigger or is the bottom getting bigger faster? Okay? So on a problem like that, remember that what does cosine x look like? Yeah, it's one of these, right? But it never gets above this or below this. Cosine x and sine x both stay in a very limited range, right? From -1 up to 1, really, is all. Okay? So you have a very limited range on top, but you have infinity cubed on the bottom. So infinity cubed is going to get much bigger than this cosine x, alright? And so this limit is going to be what? So if the bottom's getting bigger and the top's not, the top's staying within this range, and the bottom's getting bigger, then your whole limit's going to be bigger. Yeah. Can I have